Hello everyone and welcome to another problem solving session on Special Maths Academy. And today's video we are going to cover a problem from the Senior First Round Maths Olympiad 2020. That's the problem 21. And it goes like this. On a 100 by 100 chessboard, a knight piece starts from one corner of the board and moves to the diagonally opposite corner. What is the minimum number of knight moves required? So, for those of us who may not be really familiar with how a knight moves in a chessboard, this diagram here explains it a bit. So a knight that is this represented in this box right now, it can move in any of these 8 boxes with a black box in them. So how does a knight move? A knight moves first he moves 2 steps in one direction, then later on it moves 1 step in the perpendicular direction to that initial direction. So like he can move 2 steps backwards and 1 step either upwards or downwards, so like perpendicular to his initial direction. So that's how a knight moves, and it's not so difficult to see that if this knight is here, all these black boxes are possible places the knight can land, and also there's no possible place the knight can land in that doesn't have a black box. So it's necessary and sufficient. These are the only boxes that work. Now go back to the question. So the question says a 100 by 100 chessboard. Definitely that's a little bit very difficult to draw out. So but we're just going to work with an 8 by 8 chessboard. That's like the standard diagram, but somehow we just in a weird way we just assume that's a 100 by 100 chessboard. So yeah, it says the knight starts from one corner of the board to the diagonally opposite corner. So we can either say it starts from here to here, because these are diagonally opposite corners, or it starts from here to here. But I don't know, for some reasons I just want to say it starts from here to here. Both of them are very similar because you can always rotate the chessboard and you can turn this down right to bottom left. Like when you rotate that, maybe turn it over. So you can start from inside, doesn't really matter. So let's just say start from here and it stops here. And let's say these are 100 squares. This is 100 and 100. Yeah. So let's say the knight is here. Just represent the knight with a triangle. Then now, if the knight is here and wanted to land here after some moves, the question asks for what's the minimum number of moves. Minimum. You can't really find the exact number of moves. It has to be an extremum, whether minimum or maximum, or those kind of things. So let's say the knight wanted to arrive here. So now, first of all, we have to remember a knight can only move in the horizontal direction or in the vertical direction. So we have to sum up some kind of things first of all. So now for a knight to go from here to here, it means that its net horizontal movement should be what? This is this is the 100 square. This is the first one. So its net horizontal movement. And what I mean by net is the difference between number of times it moves to the right minus number of times it moves to the left. That is the net. It's meant to be equal to the horizontal difference from this last 100th column to the first column. So that would be 99. So its net horizontal movement should be 99. So it should be equal to 99. And similarly, its net vertical movement should also be equal to 99. And if you look at the knight carefully, for any of the move it makes 3 steps per move. Regardless of whether it moves up or down or side or left, it makes 3 steps. That's 1, 2, either 2 to the left, 1 up, 2 to the right, 1 down, all those kind of things. Regardless, it makes 3 steps, 1, 2, 3. It passes through 3 boxes before it arrives at the final destination for each move. So remember, the question is asking not for the minimum. So we can really form a very weird pattern like this. For example, now let's say our knight starts here. Let's say it goes up. It goes side twice. Let's say 1, 2, 3. Comes here. So this is the first move. Then after this move, let's say it goes 1, 2, 3. So this is the second move. Yeah. So let's now say it goes 1, 2, 3. This is the third move. So this is third stopping place. And let's say now it goes 1, 2, 3. So after 4 moves, you can come back to this original starting point. So imagine if a knight was playing in that weird direction it's going to like keep on going for like infinitely long, because it's never going to reach this top right corner. So that's why like this question can never like ask us to like find the exact number of knight moves, or it has to be minimum. So for like the knight to minimize its number of moves, it like makes sense for the knight never to move towards the left or downwards, because if it's to move downwards, it's going to like, remember this net means the difference between the number of times it moves upward, or difference between the number of boxes it moves upward minus number of boxes it moves downwards. So to like minimize this net distance movement, or distance, we should like try and make sure that the knight never moves downwards and the knight also never moves to the left. So those two, if we can make sure those two things are happening, to mean that it has to move a total of 99 plus 99 boxes. That's 198 boxes. This is like for the minimum, to minimize the number of moves, and that's actually what the question is asking us. So we're still on track. So then also, as I said, a knight, every move a knight makes, it moves 3 boxes. So for every move it makes, it moves either it moves 3 boxes. So the best way to like to minimize the number of moves this knight makes is like it either moves twice to the right, 1 upwards, or twice upwards and 1 to the right. If we start moving left or down, it's not so difficult to like see why we just like keep on. We can never get a minimum number of moves if the knight can move towards the left or towards the downside, because it's going to like start increasing the amount we have to like move up to reach the 99, to make the net distance 99. So let's say the number of moves the knight makes is x. Let number of moves knight makes, let it be equals to x. So as I said, it means that for every move the knight makes, it moves 3x boxes. So it means that for this for the knight to like move, like let the minimum number of moves, okay, let me say let the minimum, because that's what their question is asking us for. Let the minimum number of moves the knight makes to reach this place, let it be x. So for every move the knight makes, moves 3 boxes. So I expect it to have that 3x should be at least 198. So why should this inequality be true? It should be true because we need to like move at least 198 boxes to arrive at this top right corner. Why? Because we found out that the net distance is 99 on the horizontal axis and 99 on the vertical axis. So it must cover at least 198 squares. So that's why from here, okay, the inequality that x should be at least 198 over 3. So that is 66. So x should be at least 66. I know, we are seeing 66 in the option, but at this point, it doesn't now mean that the answer is 66. Like what it means is that the answer is at least 66, can be 66 or 67 or anything above. So that like already removes the last 2 options because they are less than 66. So now, if we want to show that the answer is actually 66, we have to like be able to bring an example. So that's how like we do things like this. We want to like find the minimum value or maximum value. We have to first of all prove an inequality. And after we prove the inequality, we have to like find the equality case. If we're like trying to like say that the inequality we proved, like actually, if the minimum occurs at the value of that we proved is less than or equals to the variable we're looking for. So here we prove x is at greater or equals to 66. So we want to like show that the answer is 66. We have to like try to find an explicit example or a way to construct an example that will involve only 66 moves. So how do we do that? Let's just say for first of all now. As I said, this is an 8x8 chessboard. It's very difficult to draw 100 by 100 because of the size and definitely. So let's just look at this construction now. Let's imagine that it starts here. This is the knight now. Remember, I said let's represent the triangle. Then it moves 2 times to the, let's say this is the first movement. 1, 2 to the right and 1 up. So then after that now, let's say this is the second movement. 1, 2 to the up, 2 upwards and 1 to the right. So now these 2 movements now, like it creates something very interesting. If you notice, so like let's now draw this whole, this is the ending point. So this is where the knight is currently now after these 2 moves. The first move I made it with red, and the second move I made it with orange. So now after these 2 movements, you can see that a knight can effectively move from this box I'm drawing now in green. It's a 4x4 box. So it means that for every 2 moves, a knight can move like from the that bottom diagonal of a 4x4 box, the 4x4 chessboard, that's if there's something like that, to the if bottom left diagonal of a 4x4 chessboard to the top right diagonal of the same 4x4 chessboard. So imagine now that if we apply this a lot of the times. Yeah, if we apply this a lot of times now, like if we do this thing 25 times, to give us that. Yeah, okay. Oh, no, sorry. So what I meant was that let's look at this again. What I meant was, like, remember, we started from this point. We now went to the red. The lines in red are like my first movement, and the lines in yellow or orange are my second movement. It's my second movement. So now, if you notice, after these two movements, what is the net distance we have covered on the horizontal axis? So the net distance we have covered is 1, 2. So here is all vertical, so we don't count it, 3. So we have moved 3 times in the horizontal axis. And how many times have we moved in the vertical axis? So these are horizontal movements. So we'll count this 1, 2, 3. I've also moved 3 times in the vertical axis. And how many moves have we made? We have made what? Just 2 moves. So in 2 moves, we are able to make 3 moves vertically. We are able to move 3 units vertically. And we are able to move 3 units horizontally in 2 moves. So imagine now, like, if we repeat these 2 moves 33 times. Like, just do the same thing. For each of these 2 moves, we move 3 units vertically and 3 units horizontally. So if we repeat 33 times, we'll see that at the end of the 66 move, we move what? 3 times 33 units vertically. That is 99 units vertically. And we could have also moved 3 times 33 units horizontally. That's called 99 units horizontally. So it means that these are movements. That's 1, 2. The first of all move the movement I labeled with the red dashes. 1, 2, 1. Move twice left, once up, and move twice up once. Sorry, move twice right, once up, and move twice up once right. So if we repeat like these 2 movements now 33 times, we'll be able to see that we move to the right 33 times 3 times. So that's 99 units to the right, and 33 times 3 times move units upwards. So this is like what is going to make us to arrive at this top right corner. Because remember what I said, we need to make sure that our net movement vertically and horizontally are both 99, because that is how the difference is. Like, this is the first row and this is the 100th. This is the first column and this is the 100th column. Like, as I said, this is an 8x8 chessboard. We can't really draw 100 by 100, so we should just like visualize that's 100 by 100. So these are movements: red, 2 right, 1 up, 2 up, 1 right. Applying this same thing, repeating this loop 33 times, we'll be able to see that from bottom right corner, from bottom left corner, we can arrive at the top right corner in just 66 moves. So that's like the most efficient way we can be. So we have been able to now find an equality case for this inequality we got here. So it means that the minimum value of x is what? 66. So the answer to this question is A, 66. That was a bit tricky. So I'll just like do a recap. So first of all, we have to like know how it moves, and after we got that, we just like had to be able to like find these net distances horizontally and vertically. And after that, we now had to make sure that we observe that to optimize our move, like to make us move the minimum number of times, we should avoid moving downwards or to the left, because it's just going to like it's counterproductive to make us reach this top right corner as quick as possible. So that's why we only move to the left and to the right and upwards to make us arrive there at the minimum number of steps. So that's just all we have for today, and I'll see you some other time. Thank you for watching.